What's up, everyone? I hope you're having a great week so far. I'm very excited for this video today because we're going to be exploring and tackling one of our student juicy questions, and I'm going to be showing you how we might structure the class or couple of classes to maybe bring that enrichment and that excitement into the classroom. So we're going to get cracking without any hesitation. Let's roll. All right, so here would be my morning slides. I wanted to kind of show you just kind of how I welcome the class in the morning. We always have a pun, have a bit of a laugh, a little bit of a learning goal, but not giving too much information about what the actual specific lesson is going to be about. And then we always have a little bit, as students come in the class, a bit of a math little challenge. This one I love is called Math Countdown. And with that 3-digit number there, you have to try and use the 6 numbers below to get to that larger number. And you can use any, you can use multiplication, division, addition, subtraction, anything that you can think of as an operation to get to that number. And you can only use each of the small ones once. Students love it. And what I love about it is that you have various different strategies to get it. And we have a little bit of a math chat for the first 5 minutes of class to get us warmed up. All right, now after that, we would start into, let's looking at maybe one of those images that we had previously asked a bunch of questions on, and what we were kind of going to have as our focus today. This one was going to be our TTC map. Try and spring some quick questions on the students, like for example, just to recall some of their juicy questions that they had asked. And when we've kind of reminded them what the image was about, we can start going through some of those questions, just reminding students some questions, for example, such as, how will subway construction like this affect the environment? How will the construction affect people that live in the area? Would it create more traffic and chaos? And of course, students love seeing their questions on the board and sharing their ideas. Will the new LRT cut down on carbon emissions because it will take more cars off the road? Pretty good, juicy question. And then this one here kind of sparks a really good idea for our next math kind of question to tackle, which was how much dirt would be dug out as you're creating these tunnels? It's a very intriguing question. I often wondered, where does all that dirt go? How much is dug out? And students can have an idea and start thinking even subconsciously about this type of juicy question. So as the teacher, you know that this question is going to be the focus of your lesson or a couple of lessons. And to get the students hooked, love using a bit of media to try and get them thinking about this process. So there's actually a fantastic opportunity here in Toronto because there's an LRT, a crosstown LRT being constructed, and there's even some videos online to spark that curiosity. So I showed a little bit like this here, and you can see not just the description of what's actually taking place and where it's going from, but the actual construction itself, how they actually bore those tunnels using those tunnel boring machines. And all of this gives the students a little bit of, gets their subconscious rolling, gives them a bit of thinking juices flowing, and gets them prepared for our big problem solving that we're going to be doing together in class. So now that students are hooked in and they know the question is going to be how much dirt will be dug out, they know the focus is going to be that LRT line, we start thinking about that process of mathematical modeling, as we can see that was outlined in the new Ontario math curriculum, and one that we like to follow because it's super important to follow steps like this. So we look and discuss that step number 1, understanding the problem, what questions need answering, what information is needed. It's very similar to that 3-act math you might see by Dan Myers and Kyle Pierce. And it's very important to get that conversation going about what's needed first of all. Now, prior knowledge comes into play here. Before this lesson, for example, we had explored circles a little bit. So students had some prior knowledge of area of circles. So students started brainstorming what they might need to figure out, like how long is the LRT, how big is the actual hole that's being made, and all those curiosities that students may have. We jot them down together as a class, first of all, and we're going to go through this problem together. Then we think about step 2, which is looking at the assumptions. And this is super important and sometimes overlooked in these bigger, juicy problems. So a lot of students, again, would love hitting up with the assumptions. We had to assume So that maybe it was just all dirt. Maybe there was going to be rocks in there. Are we going to assume that there's no rocks, or are we going to assume a certain percentage is rocks? Students were questioning and making assumptions about, well, is this just the tunnel, or is it going to be the stations as well? You can see all of these assumptions, very interesting and very critical to make those decisions about how we're going to approach this question. And then we start to think about, well, we have to create a math model and try and solve it. So before we actually tackle this math model together, first of all, so it's kind of like a three-act math, but as a class, first of all, we actually have to think about some of those things that we need. And some of those math actual concepts that we hadn't maybe explored will be brought to the forefront. So let's have a look at that now. So as a class, we would start going through a couple of these concepts. And again, we do this kind of format just to spark some curiosity about things that are needed. We're going to go through some of these concepts together. Then we're going to do some individual juicy challenges using that kind of three-act model that we're kind of modeling in class here. So I love to start with this. It's something that's called Which One Doesn't Belong. There's a fantastic website that's I'm going to link below where you can grab some of these for great kind of math talks at the start of class. I made this one here just to get students questioning and thinking about those different 2D, 3D shapes, what makes them different, talking about that space, get them talking about volume. Some of them might have prior knowledge about it. And from there, we start looking at, well, what is the difference between that 2D and that 3D shape? Ultimately trying to develop that kind of strategy for tackling volume. And from there, we tackle that strategy and talk about, what a prism is, even go back to the conversation we had about those 4 different shapes that we showed at the start, and talking about what makes a prism and how we could develop that actual what volume is, essentially looking at the area of that base times that depth or times that height. So I know I rushed through this pretty quick, but in class, this we could do a couple of examples, having those math discussions as we go, and ultimately giving the students that kind of mini lesson about, say, volume. So now they have those tools in their bank about area and volume. Now you might say, wait a second, aren't you just giving them the strategy for tackling that juicy question now? However, we're developing this together so that they know now they might be able to approach a model for solving how much dirt will be dug out. However, after we go through this rich challenge together in class, there's going to be further extensions, and that's where the real magic happens. So now we're ready to tackle our juicy question. We've done our actual initial part of things that we might need. We've looked at assumptions. Now it's time to do our math modeling. So students might have asked some of those questions that are super important. They might need some more information. So we'll give them some more information if they ask for it. The LRT is special that it goes above ground and below ground. And students have asked in the past, well, how long is the tunnel underground? So we can give them that information. So the LRT spans 19 kilometers, however, 10 kilometers are underground. So already students are thinking, yes, I got a nugget of information that will be useful there that I've already asked for and thought about. Now, also, we can play a little bit more of that video, having them look carefully at some information that they might need. As you can see here, there's some more given information that might help them in their approach. So after the students have gotten pretty much what they need, you give them some time to tackle it. They're enthusiastic, they're eager to try and figure out how much dirt was dug out. Now this next part is my favorite, and it was step number 4 in our math modeling, which was our reasoning, justifying, having those conversations, thinking of those other approaches about how students came up with their answer. Now, before the big reveal, this is a really nice question because there's an extra element. And now that you've modeled the system of problem solving, students will have an opportunity to try and go through these steps again with a slight bit of a twist. So what I love about this little video that Metrolinx created, they tried to quantify how much dirt is removed by comparing it to the CN Tower. And not only comparing it to the CN Tower, but they built a tower of the dirt with the base of it being the size of the ACC hockey rink. Love this type of question. It was a great way to quantify. However, you don't play the answer to reveal the height of that tower. You ask students to try and figure it out from what we had gathered from in class as a group. So again, students have the opportunity to ask themselves, what information do we need? Jotting down those questions. They're furiously, frantically jotting down the questions. Step 2, the assumptions, trying to figure out what's going to remain the same. Are there going to be 1 tunnels, 2 tunnels, and figuring out how much dirt they're going to need for this ACC tower. Then, of course, don't leave them in suspense too long. We'll give them some of that information. And some of that information here, as you can see, like the length of the hockey rink, the width at the center line, and the corner radius. And this is bringing in some of that prior knowledge that students would have learned and kind of giving that spiraling approach where we're revisiting concepts from previous. So now students are on their own for this one, trying to figure out a model to figure out the height of this dirt tower. And I love how this is like an extension, and it's even keeping students and building that suspense to figure out how much dirt is in and is removed from that TTC line.
The volume of material to be excavated for the crosstown tunnels will be enormous. Enough material will be removed to fill the Air Canada Centre rink to a height of 580 meters.
And that's when it really kicks off. You play that solution, the height should be 580 meters, and students are going to start that math argument as to why their answer is correct, why their answer might be slightly off, and start that rich discussion and showcasing and having that congress about the strategies they used in order to find their solution. This is where that real understanding lies, and as a teacher you can start seeing that depth of knowledge and understanding and that thinking and communication all parceled into that activity. Now, it's not over yet. If you want a further extension after that, say no more. So now that we've tackled a question together in the class, further extended by an individual component, looking at the problem-solving model, and really grabbing students' curiosity, some students had mentioned about like how the actual tunnel boring machines work and were curious even further. So I actually found this video and I posted it below as well, talking about how they actually create the tunnels. And what's really nice as a further extension is thinking, as the tunnel is dug and the material excavated, how is it kept from collapsing? And students from the video noticed that they actually lay some concrete down as they're doing it. So could we figure out how much concrete's needed? Again, students are sparked with their attention, their curiosity. They start going through the model, questioning what information they need, what assumptions are they going to make. And of course, then we can give them some information. And there is some information I've just pulled from online and the schematic drawings showing them the actual dimensions of the tunnel. And now you've extended it a little further, not just from the basic volume formula, but they have to problem solve a little further. So I hope you enjoyed today's video. I know it's a little longer than usual and there was quite a few steps to go over, but in the description below, I'm going to put the timeline of what components I'm talking about, so it'll help you kind of skip to parts that you need to maybe focus on and look at for yourself. So have a great evening. Next video, we're going to be looking a little bit at everyone's favorite, assessment, and we're going to be looking at how in our Juicy Math units, we look at assessing student development. Have a great evening. Talk to you soon.